Hi friends, is my voice is audible to you, right? If my voice is audible to you, please let me know, right? Okay, I want to say a very big hi to all of my brothers and sisters who are on the online. Okay, right, let me check. One second. Let me check how many of you people are in online. If you are in online, please say hi so that I will understand, right? Yes. So please comment on the comment section if you are in online. Say hi or something so that I will understand. And moreover, I will also understand that my voice is clear and you are able to hear that voice clearly without any disturbance. Okay, right. So coming to today's session, today's session is all about I can say it is limit state of shear part 2. Right here. Limit state of shear part 2. Okay, so today we will complete the entire limit state of shear, like how to design for shear reinforcement, right? How to check for whether the section size is sufficient to provide shear reinforcement. If the section size is sufficient for providing shear reinforcement, how to provide the shear reinforcement. So what are the clauses that are involved in limit state of shear? All this stuff we will see. Okay. So before I start the session, I just want to say a big hi to all of my brothers and sisters who are on the online. Welcome to India's largest online e-learning platform, Unacademy. Right. I just want to convey there is so much of free content is already happening in Unacademy learning app. So please install this app if you are a serious aspirant of GATE, ESE or any other competitive examination. For all educational services together, it was there in an academy learning app. You can install this, right? Because even if you want to get other free content also, like free lectures and free notes also to some extent, not completely. So you are able to get in this app also, right? Special classes. And you can follow me the say, and you can follow me in an academy learning app using this link which is given below, right? I hope you are able to see this link. After you install the Unacademy learning app, you use this link. If you press this link, it will show my profile, will show my profile, and after my profile is there, you can follow me in my profile. This is how you can do, brothers, right? Yes. And before I start the session, some people will also say, like, sir, how to take the subscription, how to take the paid course. Like, after you install the Unacademy Learning app, what is the goal that you want to select? The goal that you want to select in the drop down menu here, go and select this GATE and ESE. If you want to crack any other PSU examination, state PSU examinations, you can click that one. But if you want to crack GATE and ESE, you can keep that in civil engineering, and you can. And after you do that one, in the main menu, if you go in the main menu, you are able to see a terminology called as get subscription. Get subscription means paid codes. You are interested to take the paid course. Okay, there are so many paid courses are already happening in an academy learning app. So if you are able to take the paid course, definitely you are pretty much sure, like if you follow the structured course, definitely we are very much sure you are able to crack any sort of competitive examination with very good rank. There is no doubt at all. And after you had taken the paid course, after you had taken the subscription plus a subscription, which we people call as plus a subscription, you will have unlimited access to all the courses from India's best educators, best online educators. And definitely there is no need to go to Delhi, Bombay and Kolkata. Just by using a single code VT10, all the doors and windows of an academy will be open to you. So there is no need to go to Mumbai, Delhi, Bombay. All the topmost certificates are directly available at your doorstep if you are able to use this code VT10. Some people will say, sir, this is my first class. Please introduce yourself first. I am Venkata Tilak Uppalapati. People call me as Venkata sir. Some people call me as Tilak sir. I completed my master's degree from University of Sheffield, England, and about to complete my doctoral degree also, PhD. My background of education is completely into structural engineering. So here also in an academy, I am going to teach only the structural subjects ranging from engineering mechanics, strength of materials, against the structural analysis, concrete structures, steel structures, and finally to construction materials and management. These six subjects only I am going to tackle. Right. Some people will also ask us, sir, what is the specialty of this university? This university has produced six Nobel Prize winners. You can understand the what research potentiality of this university because it has produced six Nobel Prize winners. And one more thing, the ranking of this university is always far better than IITs and IISc Bangalore. If you take from the past 100 years, its ranking is far better than IITs and IISc Bangalore. Global ranking. Its global ranking, I mean world ranking of this university is always stood less than 100 every time. So you can understand the research potentiality and the standards in this university, right? Moreover, I just want to, some people will also ask us, sir, okay, what is your previous work experience in addition to teaching? Previously I worked as research scientist or research engineer in University of South Carolina for a funded research project completely. This is in USA, and for that research project I worked as a team lead also. And previously I worked as head of the department of civil engineering in an engineering college. This is in Andhra Pradesh, this is in India. That means I have both local experience and global experience. Being a structural engineer, I have structural design consultancy experience also. Even till today, being a structural engineer, I am giving structural drawings to my clients, and I am giving material testing reports to my clients, brother, right? Some people will say like, sir, so coming to your teaching experience, how many teaching experience you people have? You have. I have totally 12, more than 12 years of teaching experience in teaching GATE and ESE in different coaching institutes all across India. Right? This is my brief background, brother. Right? Some people will say like, sir, you asked us to download the Unacademy learning app, na? Sir, is there any other way how to follow you other than this link? I just want to convey how you can follow me, right? The first thing is, after you go to Play Store, after you go to Play Store, in the Play Store you type this name Unacademy learning app. When you type this name Unacademy learning app, brother, you are able to see this championship type of trophy symbol, and after that you install that one. When you install this one, you are definitely able to see a screen which is having on the right hand side. In this way you are able to see a, you are able to see a screen. In the screen, select this target here as GATE and ESE. This is the target or the goal what you want to achieve. Select that goal or target as GATE and ESE, and in this main drop down menu, this is the main drop down menu. In the main drop down menu, go to free classes or courses. Free classes or courses. After you move to free classes or courses, right, you in the search button here, you type the name called Venkata Tilak. Venkata Tilak Uppalapati. Right, when you type this name Venkatadila Gopalapati, then my profile is visible to you, brother. When my profile is, see, first of all you go to free classes, and then you type this name Venkatadila Gopalapati, then you follow me. When you are able to follow me, then the future coming video lectures of mine for free of cost will be notified to you. Already done free content of mine in an Academy learning app you are able to access. At the end of each and every lecture of free session, we provide generally a PDF notes that also you are able to access for free of cost. These are the advantages when you are able to follow me. This is how you can follow me, right? Okay, some people will also ask us, sir, okay, so, sir, can you? Some people will also ask us, sir. Okay, sir. 1 second. Yeah, some people will also ask us, sir, how to get the subscription, how to purchase the paid course. Can you show from the screenshots? Yes, definitely. Why not? After you download this Unacademy learning app, na, select your goal as the competitive examination, whatever you want to achieve, like GATE or ESE or maybe PSU examination, whatever that may be. And here, in this main drop down, here in this what you call, here in this main menu, go to plus courses, brother. go to plus courses. After you go to plus courses, you are able to see the terminology called as get subscription. When you are able to take this get subscription, right, definitely you are able to access all the paid courses in your particular branch that are running by Unacademy, right? So get subscription means it is the paid course. After you press this button get paid course, you will be redirected to a page called payment, right? Payment, right? So maybe you can take iconic iconic, or you can take even normal general, I mean general, what you call, uh, I can say general course also, and you can take the payment when you had purchased this, when you had gone to this payment terms, then definitely I can say like, you can pay the payment of that particular amount which is displayed there by using credit card or debit card or any other thing, definitely we can say. But by the time of payment, please aware, if you are able to use this code BT10, if you are able to use this code BT10 during the time of purchase, the faculty referral code, if you are able to use the referral code BT10, then definitely 10% discount you are bound to get. If you don't use this one, you need to pay 10 percentage extra. So that's the reason why use this code PT10 and get 10 percentage discount on all the courses in an academy learning app, right? In an academy plus, in an academy plus, plus courses means all paid courses, brother. Simply plus courses are paid courses. You need to get the subscription from in plus courses. Simple, right? This is, some people will say, sir, what is the advantage when I had taken the subscription in an academy plus platform? I can say the first and foremost advantage is in a instant doubt resolution is the first and foremost advantage, where the free users doesn't have. So, in addition to daily level classes, instant doubt resolution is possible if you had taken the subscription, get subscription in an Academy Plus. So, when you can directly chat with the educator and you can resolve all your doubts directly by talking to the educator in the class itself while the class is going on. Right, and educator will resolve all your doubts by using polls. Right, that is the first and foremost advantage. In order to crack any sort of competitive examination, in addition to daily live classes, instant doubt resolution, uh, there should have uh, there should be support of test series is there. So we are providing here also in academy, we are providing test series support like mock test series, grand test, subject wise tests, I can say quizzes. By using all this stuff, you will write those tests and you will understand at what level you people are when compared to India's, I mean, compared to an academy topmost students. You can you can understand your performance and you can compare your performance. After the comparison of your performance, if you want to increase your performance, if your performance is bad, definitely you can improve your performance by listening to more number of lectures in that particular subject, and by working out more number of tests, by working out more number of problems, by working out more number of quizzes in that particular subject, in that particular area, then definitely your performance will be increased. That is second advantage. And coming to the third advantage is there is no need to plan yourself, brother. We will provide the entire plan. All the courses that are provided by an academy are completely structured courses. By the time we frame these courses, we keep even the underperformed students also into account, such that we provide the number of hours for each and every topic. So if you are able to complete the entire course with the number of hours that are provided by us, we will not compromise in the number of hours. And moreover, if you follow that structure, you are able to complete even the test series also you will complete. By the completion of the test series and by the completion of all the video lectures, listening and understanding, synthesizing, definitely we are pretty much sure like you are able to crack any sort of competitive examination with very pretty good rank, right? Yes. Manigala Venkat Mahesh. Hi Manigala Venkat Mahesh. How are you, brother? Hope you are fine and everything is working well, right? Right. And the fourth advantage or final advantage is, Let us suppose on one day Mahesh brother is not able to access, is not able to come down to live lecture. In that case, he will be provided with the same lecture in the form of recorded version, depending on the comfort of his device, like maybe from mobile phone, maybe from maybe from, I can say, smartphone, or maybe PC, or maybe tab. So depending on his or her comfort, we are going to provide the access of recorded lectures for unlimited number of times, maybe for 1 year or 2 years, if he has taken the subscription. That is the fourth advantage. So because of all these advantages together, you are able to crack the any sort of competitive examination with very pretty good rank. There is no doubt at all. And these are some of the topmost indicators that you have. You can have directly look at them, right? And I just want to convey, the course will be taught separately in English and separately in Hindi, so there won't be any language barrier also, brother. Those guys who are comfortable in Hindi, they will listen Hindi classes. Those guys who are comfortable in English, those guys will listen to English classes. So there won't be any conflict also, there won't be any problem also. When you have taken subscription, you will be provided access to all the courses that are provided by Unacademy in your particular stream. Let us suppose some people will also ask us that till now in GATE and ESE, how many courses you people had launched, especially in civil engineering. Especially in civil engineering, we people had launched 8 courses. Out of these 8 courses, few courses are in English, few courses are in Hindi, few courses are long-term courses, few courses are short-term courses. When you had taken subscription, you will be provided access to all the courses, as every month as the pool of faculty are going to get increased, as the number of courses will also going to get definitely get increased. When you had taken subscription, you will be provided access to all the courses. But by the time of purchase, don't forget to use this code BT10, brother. If you forget to use this code BT10, 10% discount will not able to come to you. So please be aware of that. Right. And coming to the financial terms, everybody, sir, the courses are from 1 month to up to 24 month subscription. And coming to 12-month subscription course, the cost is after 10% discount is 27,225. And if it is a 24 months course, the cost is 39,600 after 10% discount. So please be aware of this, right? So how much months plan, or how many years plan you want to take, so you select that one and you can. I can recommend this 24 months course for the students who are in second year and third year students are preferred to take this course to this 24 month subscription. If you are a final year student, I can recommend either a 12 months course or 18 months course, right? Some people will also say like, so I just want to convey one more thing. Every day my class is happening in this Let's Crack Gate and ESE Civil YouTube channel, right? Every day my class is happening by 11 a.m. I hope you are able to see my class is happening in my background is structural engineering. I am going to teach structures for this month. I am going to teach RCC, right? So every day my class is happening by 11 a.m. Right. I just want to convey one more thing. I already started a Telegram group for you guys, and the name of that channel of Telegram channel name is Unacademy underscore civil engineer Tilak. If you want to come down to this channel, okay, if you want to join this Telegram channel, then use this link which is given below. If you type this link which is given below, Unacademy underscore civil underscore engineer underscore Tilak, and U capital, C is capital, E is capital, T is capital, you are able to come down to this one. Definitely, whatever may be the doubts, if you have, you are able to post your doubts, brother. Okay, right. And I will read and I will take care of your doubts if you are able to ask your doubts here, right? And moreover, I just want to convey, please subscribe to this channel, Let's Crack Gate and ESE Civil YouTube channel. Okay, then whatever may be the free courses, will be free classes that are happening in this in this Let's Crack Gate and ESC and Civil YouTube channel will be notified to you. Don't forget to press the bell icon, brother. Please press the bell icon so that the future coming videos will be notified to you. And if you want to take any sort of paid course in Unacademy Plus, use this code BT10. Please raise a thumbs up to our video so that we are able to do more free videos for you, brother, right? So coming to the today's session, is that okay, right? Shall we start the today's session, brother? Manikela, Venkata, Ramesh, Venkata Mahesh, Vasant Sai, and all the brothers who are on the online. In your previous class, if you memorize, we started limit state of shear and we started what is the definition of shear span, right? So and based on the shear span to depth ratio, different types of failures that are possible in beam we just started, and the first type of failure that we had seen in our previous classes, diagonal compression failure, right? This is over. Diagonal compression failure, this I already dealt in your previous class, right? This I already completed. Okay, now the question is, hi Shabin, how are you, brother? Hope you are fine. Right. Now the second type of failure that is possible based on here the types of failures are dependent on shear span by depth ratio. Right. So what is shear span, brother, from your previous class? Shear span is the span of the beam in which non-zero, constant or uniform shear force is happening. The span in which non-zero constant shear force is developing. That span is nothing but this shear span. In shear span, the bending moment need not be zero. The bending moment can be of some value. Such type of span, the magnitude of such type of span is nothing but shear span. Let us suppose if shear span by depth A by D, this I already teach you in our previous class, shear span by depth, and shear span by depth ratio is between 2.5 to 6. Like I hope if you had taken a one second, one second. Let us suppose if you had taken a beam, for example, in this way. I hope you are able to see at the top. There is 2 point loads which are W and W. So if this reactions will also be W. This is what is shear span, because if you take this A, the A distance is nothing but shear span, because you are able to see a shear force diagram in this way clearly. So this dimension is A and this dimension is also A, because this is shear span in which constant shear force is there, right? So this A is nothing but shear span we can write. So when shear span by depth, if more and more shear span by depth ratio, if the ratio is higher from 2.5 to 6, especially in laboratories, especially in lab, you are able to see a failure called diagonal tension failure. Now everybody will also ask us, sir, what is this diagonal tension failure, sir? I hope when you take this, if this is the neutral axis, for example, if this is neutral axis and this is a simple supported beam, brother, SSB, I hope everybody knows simple supported beam. Whatever may be the load, maybe point load or maybe uniformly distributed load, forget about. When it is simple supported beam, especially at this support, the bending at this section, what is the bending moment is possible? Bending moment is zero. Only at this section XX, I can say at section XX, bending moment is zero. That means I can say normal stresses are zero, right? Normal stresses are zero at this section, but at this section XX only shear force is possible. So at section XX shear force is non-zero. I can say if I take an element, if the name of this element, whatever maybe, if I take here, the name of this element is A, brother. The name of this element is A. So if you take the element A here, this element A is completely under shear mode only. It is completely under shear. I can say there is no normal stress, only shear force is there. Will you accept that, dear shape in Sayluddin, brother? At A only shear force is there, or at section XX only shear force is there. Will you accept that one? When you accept that one, right, from the fundamentals of strength of materials, if you take at element A or at section A, the element A is under complete shear. Will you accept? Yes, its supports are under pure shear. Very good, very good. Okay, now let me just highlight this one. Maybe let me erase all this stuff. You understood? The supports are under only pure shear. Very good. If the name of this one is A, if I had taken this element A, brother, right, it is under pure shear, like this. When these are in the shear, the perpendicular sides are under complementary shearing stresses. Maybe in such case, this is how the shear will be there, and the normal stresses are zero because there are no bending moment, so the normal stresses are zero. In this case, when the element is under pure shear, right, in such case definitely this diagonal, I hope you are able to see this diagonal, this diagonal along this direction, this is under tension, right? Let us suppose the shearing stress that is developed is tau. This is tau, tau, and tau, right? If I take a small element, what is in this diagonal, I hope you are able to see along this diagonal, this is diagonal tension. That is diagonal tension. And the maximum value of normal stress or the maximum value of principal stress is possible along this diagonal side, and the maximum principal stress is perpendicular to this plane. So if you take this plane, right, if you take this plane, maybe let me show, one second, let me show you. If you take this plane, to this plane, this stress, this normal stress is actually tensile in nature. And if you want to work out that normal stress, that normal stress is principal stress, maybe I can say sigma p1, and the value of that sigma principal stress is tau, definitely, because this is tau, this is tau. If you are able to work out principal stress, the principal stress formula, I hope you are able to one, sigma p1 p2, sigma x plus sigma y by 2 plus square root of sigma x minus sigma y by 2 whole square plus tau square. So plus or minus, if I take plus, it is maximum principal stress. If I take minus, it is minimum principal stress, I mean major principal stress, minor principal stress, I can say, right? Principal stresses are pure normal stresses. If you take that maximum normal stress, it is plus tau. So because of this normal stress, sigma p1 is tau. Let us suppose if sigma p1 is equal to tau when this is more than, for example, when this is more than permissible stress of concrete, permissible, I can say this is under tension, permissible tensile stress of concrete, then this here in tension zone, this is where I am talking. If you take, this is neutral axis, for this neutral axis, this element I had taken is in tension zone. Will you accept this is in tension zone? That in tension zone, I hope you can say that the crack will happen, and if you see this plane will act at an angle of 45 degrees. Definitely the principal stresses in case of pure shear element, the planes are at an angle of 45 degrees with respect to vertical line or with respect to horizontal line, right? So based on this one, definitely you can understand. So this is the direction in which this diagonal tension failure, I just want to show you, this is the direction in which diagonal tension failure will happen. I hope you are able to see. This is the direction in which diagonal tension failure. This diagonal tension failure is coming into a picture because of pure shear action. Because of that pure shear action only, that principal stress is developing, and because of that principal stress is with 100%. Yes, yes, brother Shapin Sayluddin. In the meantime, please take the course. If you had taken the course, then we will start, right? So in the meantime, dear Shabin brother, definitely we will tackle in plus also. Okay, right? Don't worry, right? And I just want to say, because of this crack will happen in this diagonal direction at an angle of 45 degrees here, right? And people think like this is just a normal stress crack, but that normal stress is coming into picture because of pure shear action, isn't it or not? So that is the reason this diagonal tension failure is also a failure, is a mode of shear failure only, because that is coming into pure shear action na. Diagonal compression failure, diagonal tension failure, all these two failures are coming into picture because of shear action only, right? Some people will ask us, sir, how to prevent this crack in tension zones, or this crack is coming in concrete in tension zone, how to arrest that, how to arrest the diagonal tension crack? I hope you can see it, because this crack is happening at an angle of 45 degrees, which is coming into picture because of shear action, pure shear action. To stop any sort of pure shear action, to stop such type of cracks, we need to provide proper shear reinforcement in beam. How to provide proper shear reinforcement? Maybe I hope you know, providing proper shear reinforcement can be done by using stirrups, like vertical stirrups or inclined stirrups, or maybe by bent up bars, anything we can say. By using proper shear reinforcement, we are able to avoid this type of cracks. If we are able to design for the shear reinforcement, then this type of diagonal tension failure can be avoided. So to avoid this diagonal tension failure, first thing is you need to provide proper shear reinforcement. When this type of failure will come into picture, when shear span by depth ratio. What is A stands for? A stands for shear span. When shear span by depth ratio is between 2.5 to 6, in laboratory you are able to observe only this type of diagonal tension cracks only. Diagonal tension failure is possible. So depending on shear span by depth ratio, whatever may be the type of failure that you want to see in laboratory, you keep that shear span by depth ratio. Definitely the type of failure you are able to see directly in the laboratory. Isn't it or not? Sir, if at point A was it in compression zone, if the point A was it in compression zone, in such case, dear brother, diagonal compression failure is possible, dear brother. Dear Shaybin Sairuddin, in your previous class, this is A. In your previous class, I had taken an element exactly at the support in compression zone. In compression zone, I had taken an element in compression zone. That name of that compression zone may be A dash. In such case, if one diagonal is under tension, another diagonal is under compression. Na? So in compression zone, you are able to see definitely diagonal compression failure. But in tension zone, you are able to see diagonal tension failure. That is the only difference. Here you are able to see on A dash diagonal compression failure. This is the element where you can see diagonal tension failure. Where I teach you this diagonal compression failure, brother, dear brother, if you see or if you don't see, in your previous class, at the end, at the complete at the just at the end, at the time of completion of the class, I started this limit state of shear. I had teach that diagonal compression failure is possible when A by D ratio is between, shear span by depth ratio is between 1 to 2.5. In such case, this I already teach you in your previous class. In previous class, this diagonal compression failure is already over. That's the reason why I am not teaching the same thing again and again. But anyway, if you go to the previous class, there it is there. Okay, right. So some people will say, sir, okay, we are able to see diagonal compression failure, diagonal compression failure, diagonal tension failure. See, understand, diagonal compression failure and diagonal tension failure are coming into picture because of pure shear action. Please understand that, right? So let me write that. One second. Here is note. What is the note? Both diagonal tension and compression failure in concrete is coming due to pure shear action. Due to pure shear action, the cracks are at what angle, brother? Cracks will form at an angle of 45 degrees. So whenever you are able to see at the supports, please see, this is at support. Whenever you are able to see any beam with cracks at the support at an angle of 45 degrees, okay, then definitely you can understand those cracks are nothing but shear cracks, right? Like that you can come to a conclusion, right? If cracks will form at an angle of 45 degrees because of this pure shear action. Maybe that can be by diagonal compression or maybe diagonal tension at the supports, because the shear force is more major at the supports na. So generally you are able to see, if it is shear failure, generally you are able to see a crack at an angle of 45 degrees here, at an angle of 45 degrees, like this. Yes. Now How to stop this one? By providing proper shear reinforcement. Now the question is, everybody will also ask us, sir, what are the ways how we can provide the proper shear reinforcement if you refer to IS 456? First one, by using vertical stirrups. By using vertical stirrups. Second one, by using inclined stirrups. Inclined shear reinforcement people usually call. By using bent up bars. Third one is by using bent up bars. By using these three ways, we are able to provide the shear reinforcement that is advocated or supported by IS 456. We will talk about the stirrups and all the stuff by the time we are dealing with the design of shear reinforcement. We will tackle what is vertical stirrups, what is inclined stirrups. Out of these ones, which one is better and what is the reason. We will tackle even that one also. Don't worry. And some people will also say like, sir, what is the type of failure in beam that you can see? So I am talking about types of failure in beam. I just want to convey in your previous slide. If I go to previous slide, I hope dear brother Shehbin Sehiluddin and Manigala Venkata Mahesh Vasant Sai. I hope you are able to see this one. Uh, right here, these are supports, right? Support, and these are support. I hope this is the midspan, right? This is midspan section. At a midspan section, the major thing is only maximum bending moment exists, right? But no shear force. How you can say no shear force? If you take a uniformly distributed load in this way, generally the shear force is zero. Generally at the midspan, and the maximum bending moment is possible at the midspan. So if I take an element, if I take an element exactly, uh, uh, if I take an element, if this is how a neutral axis on the mid level section, maybe this is x dash and x dash, at a distance away from this neutral axis at this midsection, maybe this is b. If I take an element at b, that element b is under pure flexor action. Element b is under pure flexor action. Now you tell me, dear brothers, when the element is under pure flexor action, you please tell me what is the type of stress that you are able to see. The type of stress that we are able to see is only, I can say, a normal stress. Only I can say normal stress, isn't it or not? Right. So when it is normal stress at this section x dash x dash, at section x dash x dash, only bending moment, no shear force. So if I take an element at a distance away from this neutral axis, okay, that element b is under normal stresses only, because only bending moment is there, right? When the element is bending, when the element is under normal stresses, if this is the section to this section, this is normal. If this is sigma x, maybe I can say this is also almost sigma x. I can write sigma x plus dx like that, right? And there is no sigma y, only this element b is under uniaxial tension, I can say, only in one direction. Now because of this stuff here, what is the direction of crack that is possible, brother? Because of this normal stress, I hope you know the only way the possible the crack is purely vertical in nature, right? So perpendicular to this face, I mean, on this face only maximum normal stresses are possible. So I hope you can say this is the crack, how it is propagating. The crack will propagate at an angle of 90 degrees with the horizontal. And what is the name of this crack? This crack is because of bending moment, because this sigma x is because of bending moment, normal stress. So these cracks are definitely nothing but flexural cracks. These cracks are nothing but, definitely these cracks are nothing but flexural cracks only. So generally whenever you are able to see in a beam. Let us suppose if you had seen in a beam, a cracks are purely vertical. I hope you are able to see when the cracks are purely vertical in this way, then definitely you can understand such cracks are nothing but flexural cracks. So what is the note that we can write? Flexural cracks propagate at an angle of flexural cracks propagate in vertical direction, right? Flexural cracks propagate in uh, vertical direction. I mean to say vertical direction means normal to the axis of the beam, or normal, maybe I can write, or normal to the axis of beam. Right? This is the axis of the beam. So normal to this axis of the beam, the cracks will propagate. Now generally concrete, this is going to happen generally in tension zone. So that's the reason why I had taken an element especially in tension zone, because of in tension zone this occurs generally at mid span, and the cracks is generally at an angle of 90 degrees only, vertically cracks. How you can stop this type of flexural failure, brother? The flexural failure in case of any flexural element can be prevented by providing proper area of tension steel. So that's the reason, as concrete is weak in tension, generally in tension zone we are able to provide the tension steel. So by providing proper tension steel, please understand, by providing proper tension steel, we are able to stop this type of flexural failure. By providing proper tension steel, or people usually call as main steel in tension zone, right? We are able to stop. So whenever you are able to say cracks in vertical direction, these are flexural cracks. Whenever you are able to see at the supports, when the cracks are at an inclined way at an angle of 45 degrees roughly, such cracks are shear cracks indirectly, maybe because of diagonal tension or maybe diagonal compression. If it is in compression zone, it is diagonal compression cracks. If it is in tension zone, it is those are diagonal tension cracks. Now everybody will also ask us, like especially Shabin brother will ask me like, sir, what is the span by depth ratio for this flexural failure? The span by depth ratio for this flexural failure, A by D ratio is greater than 6. If you want to see this flexural failure in beam, try to keep the shear span by depth ratio A by D, which is equal to shear span by depth ratio is more than 6, then practically you are able to see this flexural failure in laboratories per beam, right? The fourth type of failure in beam that you can see is flexural shear crack. So it is a rare crack. I can see this crack. I just want to show you. I just want to show you this in your previous slide. Can I rub this screen? I just want to show you this flexural dominated shear cracks. Can I show that, brother? Can I show that one flexural shear crack failure? I just want to rub the screen here. I want to talk about flexural shear crack. So for this element, if it is completely with UDL, I just want to idealize this beam as a straight line with simple supports in this way. If this is uniformly distributed load, now you people tell me a section other than at midspan and other than at supports. Maybe I had taken a section at quarter span. Maybe this is x3, x3. If I take the if I take the shear force diagram here, I hope you are able to see. This is how the shear force diagram is. There is some shear force is there at this section x3, x3, and if you see the bending moment diagram, maybe I can show the bending moment diagram clearly. Uh, if I show, this is how the bending moment sketch is. Is that okay? This is how the bending moment sketch. I hope clearly you are able to see. This is the bending moment at the section. This is shear force at the section. Bending moment is also considerable value here. Shear force is also some considerable value here. That means at this section, if you are able to see a failure at this section, the cracks are coming into picture because of the domination of bending moment and shear force. Such type of crack which is coming into picture by the combination of both the bending moment and shear force. Such type of cracks are nothing but flexural shear cracks, where you can see these flexural shear cracks at quarter spans, or maybe other than at other than at supports, and other than at mid spans, uh, other than at supports and mid span, we are able to see this type of cracks. I just want to say this type of bending dominated shear cracks. These are bending dominated shear cracks. Bending dominated shear cracks. So these are bending dominated shear cracks. So definitely you are able to see like the crack here. The shear crack will act at an angle of 45 degrees. Bending crack will act at an angle of 90 degrees. When you say bending and shear crack, it will be between 45 and 90 definitely. So that's the reason why we are able to show a crack. Here this value is more than 45 degrees and less than 90 degrees. What is this type of cracks are nothing but bending dominated shear cracks, or flexural shear crack, we can call it as flexural shear crack. So if I want to write a note about flexural shear crack, what I can say, the crack for flexural shear crack will occur at an angle of 45 to 90 degrees. Definitely these are bending dominated shear cracks, and this is a rare crack. This type of crack will not be observed generally. It's a very rare crack when both bending moment and shear force both are dominant one over the another. In such case, we are able to see this type of cracks. Now, everybody will also ask us, sir, this type of failures in what you call in beams are over. Sometimes some people will say, sir, at an angle of 45 degrees, it is shear crack. If the crack is vertical, it is flexural crack. If the angle of the crack is at an angle of more than 45 and less than 90 degrees, then it is a bending dominated shear crack. Okay, let us suppose, sir, if it is a beam, sir, okay, if the crack is happening, these are reinforcing bars. If the crack is happening parallel to the reinforcing bar, I hope you can say a crack parallel to reinforcing bar. What is such type of crack is called? Can you ascertain what is the name of that crack? The crack which is happening parallel to the reinforcing bar, that crack which is in horizontal direction, that crack is nothing but, I hope you can say, it is a corrosion crack. I just want to say corrosion crack. So maybe I hear corrosion crack. So corrosion cracks are happening parallel to reinforcing bar. Because of corrosion, the corrosion will apply uniform pressure on the surrounding concrete. So because of which that uniform pressure will be applied on the surrounding concrete throughout the length of the bar. So because of which a crack is possible along the length of the bar in this direction, in this way. So such type of cracks are nothing but corrosion cracks, right? Parallel to reinforcing bars. I hope just by looking, all my brothers and sisters right now are able to understand what is the type of crack it is. So to avoid this type, so just by looking at a beam or any structural element, right now my brother are able to say what is the type of crack it is. That crack was coming into because of shear, or because of flexure, or because of corrosion, or because of flexural shear crack failure. So like that they are able to mention the type of crack. What is the remedy? Right now my brothers are able to know, isn't it or not? Isn't it? When it is the failure is because of shear, you can understand the shear reinforcement is not proper. You need to increase the shear reinforcement. That's what I mean. You need to reduce the shear reinforcement spacing. Let us suppose if the failure is because of flexure, should understand proper area of tension steel reinforcement is not there. Proper tension steel is not provided. Maybe over steel was provided, or maybe I can say very less steel was provided, like that you can very less steel in tension zone was provided, like that you can come to a conclusion. So just by looking at the beam right now, every brother, every student of mine are able to understand what is the nature of the crack and what is the remedy for that, right? So shall we move to something? Some people will say, sir, you are talking about limit state of shear. Okay, now especially you tell me, as per IS 456, where that shear crack is possible, at what section is the shear crack is possible? Exactly at the support, is some small, some bit distance from the support in case of RCC, with the reason as per IS 456. You mentioned that, yes, I want to mention the critical section for shear, right? I want to mention location of critical section for shear when the support is under compression. I hope you can say this is a beam. I hope everybody can see this is a beam. This beam is resting on, this is the support. Is that okay, brother? Beam is resting on the support. Now, let us suppose this beam is subjected to some shear failure. So, because of which diagonal tension failure is going to get start. When the diagonal tension failure is going to get start, where the diagonal tension failure, where the critical section for shear is possible. So, I just want to say what is critical location for critical section. I can say it is the section where shear force shear force failure or shear failure we are observing. Generally, the shear is maximum at supports, no doubt. Okay, this is the support, and if you want to show the support reaction as a single point force, I can show at the middle of the support. But if you take this shear force is acting as bearing pressure, this has reaction on bearing pressure on this beam, right? Now the load dispersion from this reaction on this beam will happen at an angle of 45 degrees, that you had known from your code of practice, right? So generally the dispersion of the load, either the load reaction, there's the applied load or reaction load, the dispersion of the load will happen at an angle of 45 degrees. Now because of this diagonal tension crack from this end, at this end, definitely I can say this is how the crack will get started. Now this will get end, this is at an angle of 45 degrees, where it will get reach here, this will reach at this end point. So I hope you can say when the crack has got gone from tension zone towards compression zone in this way, this is the point where the entire failure has happened, right? So I hope you can say this is the critical section for shear force when this support is under compression. What is the nature of this support? The support is there, that is the support column, I can say. The support column is under compression. Support column is under compression, right? 1 second. Support column is under compression. The support column is under compression. This is how the failure or for critical section is here. Now you can see if this is D. This is angle is 45 degrees. What is the distance of this critical section? CS stands for critical section. Where that critical section is possible, brother? The critical section is, this is already D. I hope you know if this is D, then I hope this is small d, right? Then from the face of the column, I can say like the critical section is at a distance of small d from the face of the supporting column, then only the angle will be here 45 degrees, definitely, right? So based on that concept, if the support is under compression, critical section is at a distance of, how you can say critical section is at a distance of small d effective depth from the face of the supporting column. This is the, I hope you are able to see, this is the face of the supporting column, right? Face of supporting column. This is how we can see, right? This is the face of supporting column. Now, now after you see this one, Location for critical section for shear when the support is under compression. Okay. Now some people will say like, sir, when the support, I mean, when the column is under tension, sir, for example, when the column or then the support is under tension, at what section the shear failure is possible? I just want to see that. Is that okay? Right? So I just want to show you that location for critical section. Critical section is the section where the failure is happening. What is the mode of failure here? It is the shear mode of failure. Where is the critical? Where is the critical section? Where is the section where the shear failure is happening when the support is under tension? Please say the support is under tension. Example, I hope you know the pretty good example where the support is under tension. When the support is under tension, I hope you can see the pretty good example. This is porch, or maybe I can say a lintel, or maybe I can say portico. In case of porch or portico or anything, the projection of this cantilever, it is added to a column or maybe a wall in this way. So to this column or this wall, this cantilever projection is there because over this cantilever projection some load. Now you can say definitely this supporting column or this supporting this support, this is support is under what? The support is under tension, right now, brother? Support is definitely under tension. When the support is under tension, then you can understand, okay, from here maximum shear is generally at the support. For example, here when you take from here onwards, generally you can say shear failure will start happening from the tension zone to compression zone. Shear failure, like diagonal tension failure, will start from tension zone of beam. Now start from tension zone of beam and propagate to compression zone of beam. Now you tell me for this cantilever. I hope this type of beam or slab is a cantilever slab. For cantilever slab, you or for cantilever slab or for cantilever beam, brother, you please tell me, okay, where is the critical section is possible? I mean, uh, I can say where is the tension zone is possible. This is the tension zone. This is compression zone. Let me write. This is tension zone and this is compression zone. And that type of failure is just like diagonal tension failure, right? Diagonal tension failure. When it is diagonal tension failure from tension zone in diagonal direction towards compression side, the crack will propagate and the angle of this crack will be at an angle of 45 degrees with the horizontal or vertical. When you take this one, this is how the crack will get propagated. So where the crack is starting, the crack is starting at this section. So I can say this point, what is this point? This is exactly at the face of the support, isn't it or not? This when this support is under tension, right? So when the support is under tension, in such cases the maximum shear is possible exactly at the face of the column. Some people will also think like, sir, why can't I say the failure is here in this column? You cannot say the failure is in this column here because if you take at a CS section and maybe this section is x1 and x1, the length of this section, the width of the section is very high, but for a cross, but for at the face of the support, only the cross section depth is very less. But whereas at section x1 the cross section depth is very high. So here less stress is possible, here higher stress is possible. So that's the reason why we can confirm definitely the failure in case of diagonal tension failure in this case will happen exactly at the face of the column, at the exactly at the face of the support or column, I can say. Right, this is how you can understand about critical section for shear. Let us suppose, what is critical section for shear? So what is the name, what is the name of design shear force? Design shear force, factored shear force developed at critical section of shear is nothing but design shear force. So what is the design shear force? Generally we can say, we cannot in RCC we cannot directly say the maximum value of shear force. We can generally say it is the factored shear force developed at critical section of shear. Generally we need to, this is the definition of design shear force in RCC, reinforced cement concrete section. Is that okay? Right. So can I move to the shear design, brother? The theory for shear is over. I just want to give a procedure for how to do the shear design. Is that okay? Right. I just want to go for that. Right. Moving to that. So coming to the shear design. In the shear design here, one second. Mhm. The shear design, what are the no and what are the given parameters? The given parameters are vu may be the design shear force. Indirectly it is nothing but factored shear force developed at critical section for shear failure, right? That is vu. We can work out that vu. I hope when this is a beam, when these are columns, the columns are supporting this beam. Okay, now here, uh, when it is uniformly distributed load, these columns are under compression, right? These columns are under compression. And the columns are under compression. What is the critical section for shear from the face of the column? From the face of the column, the critical section for shear is at a distance of d from the face of the column CS. So at this section, if I do generally, uh, if I do generally this, what is the shear force at this critical section? That factored shear force at critical section, we are able to work out from the concepts of from structural analysis concepts, I can say, from SA concepts. Isn't it or not? That is, this working out this VU is easy. The width of the section will be given to you. B, the width of the beam. In case of flanged beams, the width of the beam is nothing but width of the beam. In case of flanged beams, I can say, I hope you can say this failure is we are working out for shear. In case of flanged beams, you tell me the shear is taken care by webs. In case of flanged beams, shear force is resisted by, is taken care by web. Flanges take care of bending moment, right? So that's the reason why in case of flanges beams, B is taken as breadth of the web, because I need to take the width of the web. And FCK, which is characteristic compressive strength of concrete, F5, F5 yield strength of the stirrup steel. F5, what is F5 stands for? Yield strength of shear reinforcement. I just want to convey yield strength of shear reinforcement, right? Tau c max, tau c. I just want to mention what is this tau c max. I just want to mention this tau c max is the maximum shear strength of concrete depending on grade of concrete as given in IS 456. The tau c max is a function of grade of concrete. If the grade of concrete is going to get increased, this tau c max is also getting increased. Tau c max is the maximum shear strength of concrete. So this will be given. Maximum shear strength of the concrete. It's a function tau c max is increasing when FCK is increasing. This tau c max will also get increased. Right. Now everybody will say like, sir, first of all you calculate nominal average shearing stress due to external loads. How we can calculate the average shearing stress or nominal shearing stress due to external loads? The nominal shear stress or average shearing stress due to external loads. How we can do that? nominal or average shearing stress due to external loads, which is tau v is equal to Bu by Bd. How we can write this tau v? Tau v stands for nominal shearing stress, which is the design shear stress, the design shear force. Bu stands for design shear force by cross sectional area. This Bd stands for cross sectional area of shear force, cross sectional area which is resisting the shear force. Bd stands for, in case of flanged beams, it is the web area in flanged beams. If it is a rectangular section, it is just directly we can write P into D directly. This is nominal shear stress. When nominal shear average shearing stress is less than tau C max, in such case, then you should understand, like, when the maximum developing nominal shear stress is less than maximum shear strength of the concrete. In such case, diagonal compression failure is not possible. No possibility of diagonal compression failure is there, right? Now everybody will also ask us, sir, okay, so please rub the screen first. So when tau v is less than tau c max, no diagonal compression failure. Let us suppose, when if tau v, which is average or nominal shear stress at I can say at critical section for shear, tau v nominal average or nominal shear stress at critical section per shear. If tau v is more than tau c max, if tau v is more than tau c max, so the developing stress is more than maximum shear strength of the concrete. In such case, when developing stress is more than shear strength of the concrete, by the time you are able to see, definitely diagonal compression failure occurs. So in order to stop this diagonal compression failure at the time of design itself, try to keep this developing average or nominal shear stress at critical section should be less than maximum shear strength of concrete. Like that, you need to design at the starting stage itself. If it is not satisfying, what you need to do? Redesign by increasing d. You try to increase the d such that how you need to redesign, such that redesign by increasing d such that somehow tau v, the developing shearing stress, nominal shearing stress should be less than tau c max. Then only there is no possibility of diagonal compression failure. No possibility of diagonal compression failure. Okay. Now, some people will say like, sir, okay, sir, you asked us to how we can find out this tau c max. You say we can work out tau v, which is equal to vu by bd. How we can work out this tau c max, sir? If you want to work out tau c max in code of practice, generally for your competitive examination, the tau c max value will be given, brother. Don't worry. But if you want to see where this tau c max is available in code of practice, in IS 456 2000, table number 20, maximum shearing stress tau c max is directly available. Please understand that. Okay. Now for competitive examinations, tau c max, maximum shear strength of concrete alone, that will be given, right? If you want to work out for your regular building designs, you can take from IS 456 from here, from this from table number 20. What is the observation that you can see? When the grade of concrete, this is how the grade of concrete is increasing in this direction, from M15 to M35 and all this stuff. From M15 to M35, here if you take this tau c max, that is the maximum shear strength of concrete, this value will also going to get increased. So when FCK increases, then obviously tau c max also increases, right? Till M35. From M40 onwards, they had the code has restrained the value of tau c max as what is the maximum value of what is the maximum shear strength, maximum shear stress of concrete alone for M40 and above. For M40 and above, it is 4. For M40 and above, it is 4 megapascal, 4 Newton per millimeter square, right? People will also ask us, sir, okay, so the most critical diagonal compression failure, how we can prevent the diagonal compression failure, sir? The most critical diagonal compression failure is prevented at the time of design itself by keeping tau v is less than tau c, such that you redesign, such that redesign, such that you design, such that you design. And tau c max is known and tau v is known. Now there is one more thing. What is tau c max? Tau c max stands for it is the maximum shear strength of concrete alone, right? Tau c max. What is this tau c max? Clearly, maximum shear strength of, you are able to see maximum shear strength of concrete alone. I am talking about only concrete, plain cement concrete alone. Just right. Now, some people will come and say, like, sir, tau c max stands for maximum shear strength of concrete alone. What is this tau c stands for? There is another terminology called as tau c. What is this tau c stands for? Shear resistance of an RCC beam. It is shear strength of an RCC beam. Resistance means strength, right? Can I write shear strength of RCC beam in which is including of AST, area of tension steel, and what factor this tau c depends on. See the shear strength of RCC beam, on what factors the shear strength of RCC beam will depend. I hope if you are able to see this figure which is on this left hand side in this figure, this is the main bar. I hope you can see the main bar will provide tension, right? If there is no sufficient main steel bars are there, then there is no proper double action. Supporting action of tension steel with concrete is not there. Supporting action of tension steel with concrete increases, then obviously when the supporting action of, when the grip of this tension steel with this surrounding concrete increases, when this double action which is supporting action of tension steel with concrete increases, then obviously I can say indirectly some shear strength of some shear resistance of RCC beam increases. Then I can say shear strength of RCC beam increases. That is one thing. And on what factors this shear resistance of RCC beam? If you take RCC beam, it's a combination of tension steel and concrete. And in concrete, if aggregate interlocking, if the interlocking of aggregates are good, then the shear strength of RCC beam will also be good, right? So this tau c is again dependent on the second factor called as aggregate interlocking, for which the shear strength is coming is tau c2. The shear strength that is coming into picture because of double action of area of tension steel, which is called nothing but tau c1. And third one, now when the concrete has got cracked, we can say like its shear strength is lost. But when the concrete is uncracked, concrete magnitude is there, right? Then we can, then uncracked concrete is able to resist the shear of RCC beam, right? So if you take what is the shear strength of RCC beam, directly we can say it as, it's a combination of shear strength because of double action, shear strength because of aggregate interlocking, shear strength because of uncracked concrete. So indirectly, if you take, it is depend on aggregate interlocking and uncracked concrete. These two are functions or parameters of FCK. Then FCK, when uncracked concrete magnitude is high, when aggregate interlocking is good, then obviously, then when FCK is increasing indirectly, when FCK increases, then this parameter tau c2, tau c3 also increases, right? And moreover, when area of tension steel AST increases, then double action, supporting action, double action or supporting action of tension steel with concrete increases. So because of which tau c1 increases. So I can say, so as per IS 456, IS 456 has given a proper tabular form this the tau c, that is the shear strength of an RCC beam, is completely a function of tension steel, is completely the function of area of tension steel. If you take this area of tension steel, which is PT, percentage of tension steel, which is equal to 100 AST by BD, for example. Not example, I hope you can see what is PT stands for. PT stands for percentage of tension steel. How you can work out this percentage of tension steel? If you take BD, it is the total cross section area is 100 percentage. What is the percentage of tension steel? AST is nothing but percentage of tension steel, which is nothing but PT. How you can write that PT? That PT is 100 AST by BD. That PT stands for percentage of tension steel. So let me write PT stands for percentage of tension steel, 100 AST by BD. Now everybody will cry at me like, sir, how to work out this AST? So I hope you know AST can be worked out from limit state of flexure. Can be worked out from limit state of flexure. Is that okay? VAST can be worked out from limit state of flexure. Now the question is, sir, okay, 100 AST by BD is sufficient. So now can you tell me from where, from which tabular form I can work out this tau c, which is the shear strength or which is shear resistance of RCC beam. So coming to the shear strength of RCC beam, there is no need to memorize this one. This value will also be given to you. Don't worry. So this, if you refer to table number 19, right? So if the grade of concrete is increasing, if the grade of concrete is increasing, right, definitely you are able to see this tau c is also increasing. So tau c is a function of, one is fck and is a function of percentage of tension steel. If the percentage of tension steel is increasing in this way, right, so this is 100 ast by bd, which is 100 ast by bd means percentage of tension steel, percentage of tension steel. So if PT is percentage of tension steel, which is nothing but 100 AST by BD, then in such case we can understand like, definitely when percentage of tension steel is increasing, then then obviously this tau c will also increase. When fck increases, then obviously tau c will also get increase. So here they had given this tau c value is common for common for M40 and every other grade. Still M40, beyond M40, this tau c value is reaching this tau c value is reaching a limiting value here, right? Now coming to, now I need to compare between, now the everybody's question is, sir, how to design for shear reinforcement, sir? When I need to design for shear reinforcement, how to design for shear reinforcement, everybody will also ask us. If due to loads, if because of, or if due to loads, if tau v, how you can write this tau v method? Is there any definition for tau v? Yes, there is a definition for tau v, which we people call it as nominal shear stress or average shear stress at a nominal shear stress at a critical section. How you can work out this tau v, which is vu, design shear force by bd. If tau v because of external loads is less than or equal to 50 percentage of strength of RCC beam. What is tau c stands for? Tau c stands for shear resistance or shear strength of RCC beam. If tau v is less than, that is if the developing stresses are less than 50 percentage of the strength of the beam, right? Developing stresses are, if the developing factored stresses are less than 50 percentage of shear strength of RCC beam. In such case, what is the thing that you can understand? Developing stresses are less, developing stresses are less than 50 percentage of strength of the beam. Then in such case, there is no possibility of shear failure is happen, right? So I can say when it is less than or equal to 0.5 times of tau c. Tau c stands for, what is this tau c? Tau c stands for uh, shear strength of RCC beam or shear resistance of RCC beam. If you take this for, if tau v is less than or equal to zero point 0.5 times of tau c resistance, then I can say it is safe in shear, and there is no need of safe in shear, and there is no need of minimum shear reinforcement also. I hope you know that there is no need to provide even minimum shear reinforcement also. Some people will also ask me like, sir, what are the examples? Is there any examples are there where there is no need to provide even minimum shear reinforcement also? There is no need to provide even some small shear reinforcement also. I hope you can see slabs, lintels, sajjas, sunshades. In this class, in these cases, all are something like slabs only. In these cases of the slabs, mostly the slabs, lintels, sajjas, sunsets. In these cases, generally for these cases, tau v developing nominal shear stress or average shear stress is less than or equal to zero point 0.5 times of shear strength of RCC beam. In such case, there is no need of to provide minimum shear reinforcement in these cases. These are the example for this case. Now, Shaybin Sailuddin will come and say like, sir, okay, this is okay. Now, let us suppose, sir, if the nominal shear stress at critical section is more than 50 percentage of shear strength of RCC beam and less than 1 times of shear strength of RCC beam, sir. In this case, what is the thing generally? What is the thing generally I can do? Here also, I can say that the section, the critical section for shear is safe in shear. There won't be any shear failure is possible, no doubt at all. But I hope you know the concept of secondary stresses. These are the stresses. Tau V, the stress that I am working out because of actual external loads. In that tau V, I didn't consider the factors like the stresses that is coming into picture because of secondary effects like shrinkage effect. I didn't consider. I didn't consider the effect of creep. I didn't consider the effect of temperature stresses. I didn't consider. Just I considered the external loads. The secondary effects I didn't consider while I am working out this tau V, which is nothing but nominal shear stress at critical section. So in such case, but to avoid for not future further increase, further increase in shear due to secondary stresses uh, like temperature, shrinkage, creep, etc. So in order to take care of these stresses like temperature, shrinkage, creep, I need to provide some nominal minimum shear reinforcement. These nominal minimum shear reinforcement will take care of this secondary stresses like stresses that are developing because of temperature, creep, and shrinkage. So the these stresses are nothing but secondary stresses. These are not primary effects. Okay, so in order to take care of these effects, I need to provide some nominal or minimum shear reinforcement. That too in which form? As far as IS 456 is concerned, you can provide shear reinforcement by using vertical stirrups, by using inclined stirrups, and by using bent up bars. Right, and the combination of bent up bars and anything. Right, so in these three ways you can provide. But if by the time you are designing only for the minimum shear reinforcement or nominal shear reinforcement, you need to design that nominal shear reinforcement only in the way of vertical stirrups. Why vertical stirrups only? Because for vertical stirrups I can say, why only vertical stirrups? uh, Vertical stirrups are more stable than inclined stirrups where man in form work. In form work, if you keep inclined stirrups are very good in resisting shear, no doubt, than vertical stirrups. But the major problem with inclined stirrups are those are not stable in form work. So that's the reason why we don't use inclined stirrups for the design of minimum shear reinforcement. That minimum shear reinforcement generally we will provide in the form of vertical strips. Now coming to this minimum shear reinforcement, now everybody will talk like, sir, what is the minimum shear reinforcement? How you can design for minimum shear reinforcement? I hope you can see. So the minimum shear reinforcement, here we can write as from this equation ASV by, this is F5 brother, ASV by B into SV is equal to 0.4 by 0.87 Fi. Before that one, I just want to show you one thing, right? I hope, can I rub the screen here? Just let me rub the screen. There is all link on the slide. If you are able to see, this is the figure that you can understand. So in which direction the shear is possible? Now the beam is under flexor, right? Now the beam is under flexor. So because of the beam is under flexor, definitely you can see the shear action will be in this direction, right? Now because of this shear action is in this vertical direction, to compensate this shear action, complementary on mutually perpendicular direction, complementary shear stresses will develop. That is in this direction. Maybe I can say maybe in this direction and maybe in this direction. That means here if you see the direction of shear effect in case of beam is happening in horizontal way in this direction. This is the direction of shear effect in beam, right? This is because of complementary shear stresses that we can say in this direction also shear effect is there. Now the question is, okay, now the question is, sir, when the shear force is happening, when the shear force is developing along in horizontal direction in this way, now on what area, what is the, on what area you are able to observe that shear force? I hope you can see when the shear force are happening in this horizontal direction. I hope when this is in 3D, three dimension way, I hope you are able to see. Now the same stuff, one second, uh, same stuff, this same stuff how I can show here with the help of a tip, ballpoint tip. Maybe this is how I am extending the reinforcement on this side. This is how the reinforcement is, right? Now where I can show the shear is happening on the on this way, in on this side, in this way. This is how the shear force is developing. When you see this shear reinforcement, the shear force is happening in this horizontal direction on a width of, if you take SV stands for the spacing. If you take what is the shear force that has got developed between the two stirrup, this is one stirrup and this is another stirrup. What is the shear force that is has got developed between this shear stirrup spacing SV, and that shear force is acting over a width of, what is this one, B. So what is the shear force area over which you are observing the shear force is developing over an area of B into SV? So shear area is B into SV, right? So per spacing, what is the per spacing of SV, what is the shear reinforcement area that is there? ASV is the area of shear reinforcement. ASV is the area of shear reinforcement per SV spacing. So in such case, if you take ASV is the area of the shear reinforcement for per a spacing of SV, and it is acting on for a width B. In such case, if I take this one, ASV by B into SV, if you take this one as, this is using this equation, this is the equation for minimum shear reinforcement. ASV by B into SV is equal to 0.4 by 0.87 Fi. Using this equation of IS456, we are able to work out the minimum shear reinforcement. Now everybody will also ask us, sir, what is this ASV, sir? ASV stands for area of shear reinforcement. So how you can say, if you take this, there are if you take this shear reinforcement, I hope you can say this is how many legs are there here, brother? How many legs are there here? It's a two-legged vertical strap. There are two legs here. If you take the shear force is happening in this direction, na? So here you can understand how many legs are there. Two legs. So I can say ASV. How I can write ASV stands for, I can say number of n into pi by number of legs into pi by 4 into diameter of single stirrup leg. What is the diameter of single stirrup leg into phi square? This is how we can write, where n stands for, where n is equal to number of legs in stirrup. Maybe here if you see it's a two-legged vertical stirrup, here you can see this is one, and maybe let me show you clearly. uh, this is one leg, and this is one leg. Here it's a two-legged vertical stirrup. For here, if I had gone for three, let us suppose here, let us suppose in the cross section there are three elements are there. Here there is a link was given in this way, but to provide proper confinement, there is another leg was kept, another hook was kept here. Here if you take the cross section, how many legs are there? One, two, three legs are there. So it's a three-legged vertical step. I just want to say ASV stands for area of area of shear reinforcement per spacing SV, which stands for number of legs into pi by 4 into diameter of the stirrup leg, where phi stands for diameter of stirrup leg. Is that okay, brother? Right. So using this one, now some people will say like, sir, what is the percentage of minimum shear reinforcement? Please understand, we are not keeping the shear reinforcement in the cross section. We are keeping the shear reinforcement on an area of, on the area of B into SV, right? So I can say shear area is B into SV here. So with respect to this shear area, what is the percentage of shear reinforcement we need to mention? So for a reinforcement, for an area of B into SV, the for an area of B into SV, the shear reinforcement area is 100%. What is the shear reinforcement area when I can say when the area is ASV? The area of shear reinforcement is nothing but percentage of minimum shear reinforcement. So I can say, I can percentage of minimum shear reinforcement PMS. How you can work out this PMS value, brother? Two chocolates cost 5 rupees. What is the cost of seven chocolates or one chocolate or whatever that may be? In such case, if you do the direct proportionality, that PMS, how you can write as 100 into ASV by B into SV, right? So if you see, this is the equation from where we can work out spacing of the shear reinforcement. From this one we can work out spacing of minimum shear reinforcement. Minimum shear reinforcement, RFT, workout spacing, right? Workout spacing for minimum shear reinforcement. Okay, now the question is, what is the percentage of minimum shear reinforcement? Just for this ASV by B into SV, just multiply with 100, then you are able to get the percentage of minimum shear reinforcement. So it is 100 ASV by B into SV. For an example here, if the area of shear reinforcement ASV is I can write, if the area of the shear reinforcement is not known, but based on this one, what is the percentage of minimum shear reinforcement you can keep? It is zero point 0.4 into 100 by 0.87 times of Fi. If you know the grade of steel, then definitely you are able to work out the percentage of minimum shear reinforcement. Let us suppose, brother, dear brothers, can I move to the next slide, brothers? Brothers Shebin Sailuddin, Manigela, Venkata Mahesh, Vasant Sai, any other person who are on the online, right? Can I move to the next slide, brother, to show you an example? Can I rub the screen here? I just want to rub the screen first. Before I rub the after I rub the screen, let uh, if yield strength of if Fi is yield strength of shear reinforcement, then what is the percentage of minimum shear reinforcement? How you can keep, if the percentage of minimum shear reinforcement in this is yield strength of minimum shear, if the example is 415 megapascal, Fe 415 I am using as minimum shear reinforcement is zero point 0.4 into 100 by 0.87 into Fi. I can write this Fi as 415, which we can work out as 0.12 percentage of shear reinforcement. This 0.12 percentage of this cross sectional area B into SV. So within this cross section area of B into SV, I need to provide this much minimum percentage of shear reinforcement as 0.12. Like that we need to work out. right? And some people will also ask us, sir, you had made this from this equation, this is not fg, this is fi. Everybody will say like, sir, what we can do? I can say simply like, from this equation we can find the of spacing of minimum shear reinforcement, minimum shear reinforcement. And there are certain checks also there for minimum shear reinforcement spacing. If the minimum shear reinforcementing is more than some values, we should always check the spacing of minimum shear reinforcement should be less than some particular values. I just want to show you that. So coming to that, if I use Fe 415 grade of steel, for example, I use Fe415 grade of steel, and percentage of minimum shear reinforcement is 0.12. Okay. Now here everybody will say like, sir, how you can work out the spacing of the shear reinforcement? If n stands for the number of legs, then you can write ASV is equal to n into pi by 4 into diameter, where phi stands for diameter of stirrup reinforcement, vertical stirrup reinforcement. Diameter of vertical stirrup reinforcement. Okay. And after this I hope you know ASV you can work out, you know ASV, B you know, SV I don't know, I need to work out this one. Point 4 I know, FI also know. So generally we use mild steel as the shear reinforcement. Note, generally we use mild steel as shear reinforcement to achieve high ductility before shear failure. Generally, if you take in case of earthquake regions and in case of cyclonic regions, especially at beam column junctions, most of the failures are because of coming into picture because of shear failures. If the shear failure is happening before shear failure, if I want to ensure more ductile failure, then in such case the stirrup reinforcement should be of low carbon steel. So the low carbon steel is obviously mild steel, na? So I need to provide mild steel as the shear reinforcement to achieve high ductility than HYSD steel. Okay, right. So from this one, I can work out the spacing of this shear reinforcement. After I work out spacing of this shear reinforcement, if you see the value of the spacing of this minimum spacing, SV minimum spacing of this minimum shear reinforcement, maybe spacing of this minimum shear reinforcement should always be less than 0.75 percentage of effective depth and should be less than 300 millimeter. Out of these three values, SV minimum 0.75 times of t and 300, whatever may be the lesser value, we generally fix that value for minimum shear reinforcement. I can simply say like maybe here, let me write a note here. mm, Lesser of SV minimum, comma 0.75 times of D, 300 millimeter is fixed as minimum shear reinforcement spacing. Is the note that I want to convey. Note. Right. So now some people will say, sir, let us suppose, sir, you are talking this when tau v is greater than greater than 0.5 times of tau c. Let us suppose, sir, when tau v is greater than tau c, sir. Let us suppose, sir, if tau v is greater than tau c, what is the conclusion that you can write? Not safe in shear. Then that section is not safe. Then in such case, The section is not safe in shear if I don't provide shear reinforcement. Shear reinforcement design is required. Previously, I had provided some nominal shear reinforcements just to take care of stresses due to secondary effects like temperature, creep, shrinkage. But shear reinforcement is design is really required. How the shear reinforcement can be provided? The shear reinforcement can be provided by vertical stirrups, by inclined stirrups, and by bent up bars. Now, what is the note that I can say here? The note that I can say is most effective out of these three is inclined stirrup. Most effective is inclined stirrup, but these inclined stirrups are not stable in form work. So that's the reason why in practice vertical stirrups are commonly used, right? Commonly used is vertical stirrups because vertical stirrups are more more stable in form work. And coming to this bent up bars, some people say like, sir, what are these bent up bars? Like especially if you take a beam here in this way, this is having a support and this is having a support. Let us suppose there is completely a uniformly distributed load is there. Generally, if you take, this is how maximum bending moment is here. But there are no maximum, this is maximum bending moment. And if you come to shear force, this is the maximum shear force is there. Now, generally here at this mid span, here if I work out, if I take at section XX, there are at this bottom zone at section XX, if I take, there are four bars are there, one, two, three, four, right? But at this, maybe at this is section X1, X1. This I can say section XX. So if I take this main steel, the main steel are more at the center, but at the end, the main steel required are not that much. Just to use this shear reinforcement, just two stirrups are sufficient, right? Maybe two stirrups are sufficient at this support just to take care of shear reinforcement. Here I can say simply, sir, this is how the reinforcement is there, right? Here at this one, there are four bars of uh, 16 hash, okay, but here at this section only two bars of 16 HYSD bars. Okay, now everybody will say like, sir, what are the remaining two bars have happened? Just to keep the shear reinforcement here from the from the quarter span, maybe I can say from quarter span clearly two bars are I am bending up. I am bending up two bars and I am keeping that to compression zone. Here also at the quarter span on this right hand side, two bars I am bending up and I am keeping that at the tension zone. So please, 1 second, 1 second clearly. Hmm, there's no bars. There are no vertical bars. There are no horizontal bars on the compression zone at section XX. But if you see, 1 second. But if you see the same section, this is section X1, X1. At section X1, X1 here at this bottom, there are only two steel rods are there. Two steel rods are bent up. Here, how many steel rods are bent up here? You can say 216 hash are bent up bars. So out of four, two were run throughout, two were bent up. As two were bent up here in from tension zone to compression zone here, because of this bent up bars also some resistance for shear is coming. Where that resistance for shear is very much required, the resistance for shear is very much required maybe within this at the support. So just for the sake of the shear reinforcement I need to provide, I had kept some bars for bent up, some shear reinforce from shear, some shear resistance will also come. Moreover, in addition to this one, I can definitely keep the stirrups. I hope you can see this. I can definitely keep the stirrups here at this support. So because of the provision of these stirrups and all this stuff also, definitely you can understand like we can provide design shear reinforcement. And in addition to that one, because of bent up bars are optional, if we bend the bars, because of this bent up bars also directly I can say shear resistance will also come. Shear resistance will also come. So instead of reinforcement curtailment. Instead of reinforcement curtailment, the best way is if we bend the bars from tension zone to compression zone, especially at the supports, at the support region. That will increase the shear, that will increase the shear strength of the RCC beam. And moreover, when the tension reinforcement has brought to compression reinforcement, especially at this supports, we are able to design even the shear reinforcement also. That is how we can achieve economy also. I just want to convey, right? So bent up bars are optional, right? Bent up bars are optional. Generally the angle at which the bent up bars will happen is at an angle of 45 degrees, is at an angle of 45 degrees. So I one more note is directly bent up bars cannot be used. If you just bend the bars from tension zone to compression zone, it won't be any useful. In addition to this bent up bars, these cannot be used along, cannot be used alone. This cannot be used alone to resist shear, but can be used with the combination of vertical stirrups or inclined stirrups. So I had used these bent up bars here clearly. These are bent up bars. These bent up bars are used in association with the vertical reinforcement or inclined reinforcement. That's how the code asked us. These bent up bars are optional. If you are using bent up bars, don't use bent up bars alone. In addition to bent up bars, use the vertical shear reinforcement or or inclined stirrup reinforcement. Generally, all the time you try to provide vertical shear reinforcement only, because vertical shear reinforcement, vertical stirrups are more stable than inclined stirrups in forward, right? Yes. Right. This is, some people will say, sir, how these inclined stirrups are. These inclined stirrups are there, like, this is how the stirrups are there. The angle of these inclined stirrups with the longitudinal axis. This is the longitudinal axis, brother. With respect to the longitudinal axis of beam, the angle of inclination of this stirrup with the horizontal, I can say. The angle of inclination of this stirrup with the angle of inclination of this stirrup with the longitudinal axis. This is alpha. This is alpha. So alpha is the angle of inclination of this inclined stirrups with the longitudinal axis of the beam. Angle of inclination of inclined stirrups with the axis of the beam, right? Like this you need to work out. Is that okay? Right. Right. Now coming to, let us suppose some people will say, sir, everybody will also ask us, sir, if you take for what shear force I need to design for this vertical stirrup, sir? Because if you take the design shear force, VU stands for design shear force. Out of this design shear force, some shear force is resisted by RCCB. Some shear force will be resisted by RCCB due to double action. I can say double action of AST because of uncracked concrete, and I can say aggregate interlocking. Because of these three, some shear force is already resisted. For what shear force I need to design the shear reinforcement, right? So the shear force for which I need to design the shear reinforcement. Shear force for which I need to design the shear reinforcement. Shear force for which I need to design the shear reinforcement. How you can do this one, brother? You can do this definitely by using Yeah, by using this. If VU is the design shear force for which I need to design the shear reinforcement is VU, I mean design shear force minus shear force resisted by RCCB, right? Shear force resisted by RCCB, I can write minus, which is equal to shear force resisted by RCCB. How you can do this one, which is VU minus. So if the design shear force for shear reinforcement is VUS, if we design shear force for shear reinforcement is VUS. Shear force for which I need to design the shear, which is people usually called as VUS. So VUS is equal to VU minus. Now you tell me what is the shear force which is resisted by RCCB. The shear strength of RCCB multiplied by shear area. The shear strength of RCCB is tau C, and it's the shear area is B into D. So minus I can write tau C into BD. This is how you can do. For the shear force, I will design the vertical shear reinforcement. By using vertical shear reinforcement, if you want to work out the spacing, for vertical for vertical stirrups, how you can work out the spacing. So coming to this one, if the shear reinforcement, if the shear force for which I need to design the shear reinforcement is VUS into SV. This is definitely is equal to 0.87 times of Fy into ASV. This ASV you can write as it is equal to number of legs of shear reinforcement. When it is two-legged stirrups or three-legged stirrups or four-legged stirrups, n into pi by 4 into d phi square. This d diameter, d is the depth of the section, effective depth of the section, effective depth of section. This is known, ASV is known, FY is known, VUS is also known. In this one, the one and only unknown is SV. From this equation, we are able to work out SV. After we work out SV, I need to compare this SV is how we can work out this SV. How we can work out this SV? I can say use this SV that we get from this above equation should be minimum of the following. The SV that we got from this above equation should be less than or equal to minimum shear, not reflection, man. This is reinforcement. Should be less than or equal to minimum shear reinforcement. This SV that we are working out should be less than or equal to 0.75 times of D divided, and this SV that we are working out from for this vertical step should be less than or equal to 300 millimeter. I hope I already teach you, not hope, I already teach you in your previous slides how to work out the spacing for minimum shear reinforcement. I already taught how to work out spacing for minimum shear reinforcement, right? How to work out the spacing for minimum shear reinforcement. This was already known to us. Now, if you please excuse me, can I move to the next slide, brother? Brother, can I move to the next slide? Right. So coming to this inclined steps, I hope this is a bar is there. Out of four bars, let us suppose there are four bars are there. Two bars are actually bent up here. Two bars were actually bent up here. So by the time these are bending up, the angle at which these bars are bent up with the longitudinal axis is nothing but alpha. Generally, by the time of bent up here, stress concentration occurs. So please be careful. So please be careful, right? So stress concentration failure may be possible by the time of bending. Please try to bend. Don't try to bend more than 135 degrees, right? Now these are bent up bars here clearly. These bars are clearly bent up bars. Now when it is for an inclined steps, I hope when you had done this design by inclined steps. For inclined step spacing, what is the thing that you can see? Same just like vertical step spacing. How we had designed the spacing of vertical steps. VUS is equal to 0.87 FIASV into D by SV. This is common thing. But additionally, what is the extra thing that had came for vertical steps? It's a combination of multiplication of sine alpha plus cos alpha. This is the extra terminology, extra term that has came into picture. What is alpha? Alpha is the angle of inclination of this bent up bars with the longitudinal axis. Bent up bars with horizontal axis, horizontal or longitudinal axis. This is how we can say. Now coming to this one, everybody will also say like, sir, this is from this one, you know VUS, you already know VUS. How you can work out VUS? Shear force that needs to be resisted by stirrups. VUS is equal to VU minus shear strength of RCC, which is tau C times of BD. This is known to me. F by yield strength of the shear reinforcement known to me. ASV known to me. How you can work out ASV? N into pi by 4 into phi square. D is known to me. Alpha, the angle at which the bars are bent up. This angle is also known. Generally, this alpha will be 45 degrees. Alpha should be greater than or equal to 45 degrees. Generally, we know that one. So from this one, the one and only unknown is SV. So from this equation, I can work out SV will be worked out. Now everybody will say like, sir, what is the value of this SV should be? SV for vertical, SV for inclined stirrups. SV for inclined stirrups spacing should be less than. I can say the first and foremost thing is this should be less than minimum shear reinforcement. I can say. One second. SV should always be less than or equal to minimum shear reinforcement. SV minimum shear reinforcement spacing should be less than or equal to 300, should be less than or equal to here it is for inclined steps na. For inclined steps it should be less than or equal to D. So these are the conditions. These are the conditions that you can check. What is the difference between the limitations of the spacing for vertical stirrups and inclined stirrups? For vertical stirrups, here it is 0.75 times of D, but whereas for inclined stirrups, here this value is D. That is the only difference. The remaining thing is all one and same, right? Right. Now, can I rub the screen, brother? If you please excuse me, right? Brothers, can I rub the screen? Yes, let me rub the screen. Right. Coming to this, okay, after I rub the screen, now the question is, sir, okay, this is fine, no doubt. Now the question is, what is some people will say like, sir, because of bent up bars also some shear reinforce, some shear will also be resisted, na. So what is the shear strength of bent up bars? What is the shear strength? Shear strength of bent up bars. How you can work out the shear strength of bent up bars? If BUS1, if VUS1 is the shear strength of bent up bars, which we can write as 0.87 Fi ASV into sine alpha. What is alpha stands for? Alpha stands for the angle. What is this alpha here, man? Here this alpha here for this one is the angle of inclination of this inclined stirrups. I hope if you can see the angle of inclination of this inclined stirrups with this axis is nothing but here this alpha is angle of inclination of inclined stirrups with horizontal axis. This is what is alpha we mean to say. For if these are inclined stirrups. If if for bent up bars, alpha is the angle at which the bars has got bent. That is nothing but alpha. In such case, here this alpha is angle of bent up bars with horizontal, with horizontal. So you can work out this VS1. And there is a conclusion. There is one more clause is there. The clause, one more clause is if you take for if I need to resist the by using shear reinforcement, if I need to resist 100 kilonewtons by using shear reinforcement, then by using bent up bars at max I can resist only 50 percentage of the shear force to be resisted by shear reinforcement. That is, this VUS1 should not be greater than the shear force to be resisted. The shear strength of bent up bar should not be more than 50 percentage of shear force to be resisted by shear reinforcement. Should not be greater than 0.5 times of VUS. So where VUS is stands for shear force to be resisted by shear reinforcement. So that means which is VU minus tau C BD. Okay, everybody can do this. Now, what is if I got the shear force that is resisted by bent up bars is VUS1. So if I write VUS is equal to VUS1 plus VUS2, then in such case, what is the shear force that is resisted by stirrups? So shear force that is resisted by stirrups. What is VUS2? Shear force that is resisted by stirrups. So I can say VUS2 is equal to VUS minus VUS1. So if you take VUS2, that if I want to resist that with the help of I can say vertical stirrups, then I can directly equate this VUS2 is equal to 0.87 Fy ASV into D by SV. This is how you can work out the spacing, right? This is the conclusion, brother. What is this conclusion? This is the conclusion. So the shear strength of bent up bars, should not be more than 50 percentage of shear force to be resisted by shear reinforcement. That is the conclusion that we can see, right? Now the entire theory is over. Now shall we work out the problems, brother? Right? Right. So as the time has got over, so for tomorrow we will work out the problems and we will see even limit state of what you can say. Tomorrow we will see even limit state of torsion also. There are five to six problems were there in this limit state of shear. After that, after those six problems, I will start working out limit state of torsion. Okay, so tomorrow I will take more like 3 to 4 hours. Definitely I will take and I will complete. Right. So for today, if you please excuse me, right, I just want to convey, if you are a serious aspirant of GATE or ESE and if you want to get 12 months course, in such case the cost for 12 months subscription after 10% discount is 27,225 in Unacademy Plus. In Unacademy Plus. Okay, and if you want to take 24 months subscription, I can recommend this 24 month subscription if you are a student of second year or third year. Then in such case the cost is 39,600, right? So if you are a serious aspirant, I can definitely recommend you to take this subscription, brother, which is very very much required. And every day my class is happening by 11 a.m. Every day my class is happening by 11 a.m. So don't miss our classes. So I am teaching in this GATE Rankers 2021 batch concepts through questions, and in this Let's Crack GATE and ESE Civil UIT YouTube channel. So don't forget to subscribe to this channel also, right? Hit the bell icon for notifications, right? And please subscribe to Let's Crack GATE and ESE Civil YouTube channel also. If you subscribe to this channel, you will not miss even a single video that is coming from this channel. One thing, right? And when you press this bell icon, what is going to happen? The future coming videos will also be notified to you. Whenever a video will come, that will be notified to you. So so press or hit the bell icon also. And moreover, please share these videos to your friends, brother, because all you are getting this for free of cost. Let your friends will also get learn from this free class at least. And moreover, so much free content is happening in this YouTube channel also, and more free content is also happening in Unacademy Learning App. I can recommend you guys to come down to Unacademy Learning App. You can enjoy more features also, right? There is some notes is also there. Moreover, I want to convey you like, please share this video and please raise a thumbs up to this video, so that we can do more free content for you, so that it will be mutual beneficial for you and to your friends, right? So please share this video, right? Thank you very much. And moreover, before I end up the session, I just want to convey, I already started a Telegram group, and the name of that Telegram group is Unacademy underscore Civil Engineer Tilak, right? And in this Telegram group, if you press this link, after you press this link in this Telegram group, you will be redirected to my page. When you redirect to my channel, then definitely whatever may be the doubts, you can post your doubts there, and definitely I will answer your doubts. If you come and if you come and if you post your doubts directly in this Telegram group. Thank you very much. End of the session.